Welcome to this video abstract for our presentation at the 2021 Fall Meeting of the American Geophysical Union. This presentation is based on a perspective article cited below. So let's begin our tour of the bark side of the water cycle. Huh? Why go on this tour with us? Well, to date, the perspective of scientists studying forest-water interactions has heavily focused on leaves. This has left the roles of bark understudied, oversimplified, or simply omitted from the forest-water cycle altogether. Of course, none of these things are inherently problematic to advancing a discipline's theory or operational practice. So, this perspective outlines the relevance of bark-water interactions to just that, to advancing theory and practice in ecohydrology. First, let's take a look at what we'll call the geography of bark. After all, bark is almost everywhere in forests. Spatially, it's expansive, and temporally, it's persistent. Therefore, its interactions with the water cycle may be as well. How expansive is the global bark surface exactly? Well, we don't have a good estimate at the moment. But based on common data used in land surface models, it's nearly as large as the Asian continent, or about 41 million square kilometers. Sure, this appears modest next to the 1 billion kilometers squared of global leaf surface area. However, unlike many leaves, the bark is present across all seasons. Of course, some plants do shed their bark, but bark shedding, unlike leaf shedding, can increase the area for bark-water interactions, and it places bark in the understory and the litter layer. In the litter, it can hang around a while, with decomposition half-lives of 5 to 10 years. Thus, bark can be present in wooded watersheds all year round, on live and dead plants, from the canopy top to the litter below. That's a lot of bark. And all that bark has been formed with anatomical features that affect water's movement through the forest. When trees make their bark, they can give it several layers. Some of the layers consist of live cells to the inside of the tree, and some of dead cells to the outside. Starting from the outside in, the outer bark intercepts liquid and solid water during rain, fog, dew, or snow. Between these wetter periods, the outer bark can absorb water vapor. Some of the water stored in the outer bark can pass into the inner bark and be stored there, or even taken fully up by the tree. In fact, water storage in the inner bark could be a crucial buffer against daily to seasonal periods of water stress. Through these interactions with water, bark can influence other processes in forest ecosystems. For example, the storage of water in bark can influence which plants can live in the canopy, from the societally entrancing orchids to the more simple plants like lichens, that despite being less broadly admired still play important roles in forests. Multiple studies report that bark interactions with precipitation can increase nutrient supplies to soils, or that bark can take up valuable nitrogen resources from precipitation. Internally, bark water uptake and its storage of carbs may help trees repair their own embolisms. Even after death, bark may continue to influence water cycling as fallen limbs can alter soils to help them retain soil water. As the dead bark decomposes, recent work suggests that it can affect who lives in the nearby soil microbial community. So with these points in view, we conclude that a broad perspective of bark-water interactions is currently merited in forest ecohydrology. We urge this research community to more comprehensively consider the roles of bark, to test the conditions under which the bark side of the water cycle may be relevant or may be ignored. In this way, future work on the ecohydrological roles of bark, whether thick or thin, may provide key insights to forest ecosystem functions through thick and thin. Thanks for watching. If you'd like to read more about the bark side of the water cycle, please visit our research topic at Frontiers in Forests and Global Change. Or, if you find research articles to be a bit unpalatable for your cognitive gustatory cells, please visit our collection of short articles written for and reviewed by kids for Frontiers for Young Minds.